Good morning, friends. Welcome to the series of Multiplexer. So in last video, we have seen that the implementation of 4 is to 1 mux and 8 is to 1 mux using 2 is to 1 mux. But in this video, I am going to discuss the implementation of 8 is to 1 mux using 4 is to 1 mux. Okay. So in the last video, I discussed three basic concepts of implementation of higher order multiplexers from lower order multiplexers. Step 1 was match the number of inputs. Second, match the number of select lines. And third, try to get the only one output. So for 8 is to 1, for 8 is to 1 mux, we have 8 input lines and 3 select lines. 3 select lines, S2, S1 and S0. And we have 8 inputs, I0, I1 and I7. One output function. This is the 8 is to 1 mux. On the other hand, in 4 is to 1 mux, we have 2 select lines and 4 number of inputs. 4 number of inputs, I0, I1, I2, I3. So if I use the concept of matching the number of inputs of higher multiplexer which you want to implement. So first is the match the number of inputs. If I want to create the 8 inputs, then we have to use simply 2 4 is to 1 mux on the inside the first stage. At the first stage, we have to use 2 4 is to 1 mux. So this is your S2 and S1. 2 select lines are used and rest 4 inputs are I4 to I7. But on the basis of this, we have get 1 and 2 outputs and 2 select lines are used. But now the point is, can we use one more 4 is to 1 mux? But the simple point is that we are now remained with only one select line. We are now remained with only one select line because these two select lines S2 and S1 has been used in this stage of 4 is to 1 mux. Now we are left with only S0 as a select line and 2 inputs only. So we can use here 2 is to 1 mux. We cannot use here 4 is to 1 mux. So this was the concept I said in last class that I will discuss. If there is an implementation of 8 is to 1 mux using 4 is to 1 mux, then we can use only one stage of 4 is to 1 mux. Only we can use one stage of 4 is to 1 mux, and in second stage we have to use 2 is to 1 mux. So we cannot say that we can directly completely implement the 8 is to 1 mux using 4 is to 1 mux. But we have to use one more multiplexer, which is known as which is 2 is to 1 mux. So there is one generalized formula of implementation of higher order multiplexer using lower order mux. So before that, if I implement 16 is to 1 mux using 4 is to 1 mux, then we will see that all implementation will be done by 4 is to 1 mux only. So if in this next example, I implement 16 is to 1 mux using 4 is to 1 mux. Okay. So if I take this particular thing, then we'll see that in 16 is to 1 mux, we have 4 select lines and 16 inputs. We have 4 select lines and 16 inputs. So these inputs are I0 to I15. These inputs are I0 to I15, and there is one output and 4 select line S3, S2, S1 and S0. Now, if I use the 4:1 mux, then for matching the inputs, first condition is to match the inputs. So we need 4 multiplexers of 4:1 mux to match the input condition. So there are 4 inputs. More 4 inputs are here. More 4 inputs are here. And finally, rest 4 inputs are here. So from this point, I naught to we'll get I is 15 at this end. And as these are 4:1 mux, so we need 2 select lines. S3, S2. Now we have 4 inputs. Sorry, 4 outputs of these 4 mux. So we can use one more stage of multiplexer 4:1 mux. Okay. So this is the one more stage of 4:1 mux. Here we can use 2 more select lines S1 and S0. And finally, we have one output. So in this way, we can implement 4:1 mux using, we can implement 16:1 mux using 5 4:1 mux. So this is the structure inside, which is the implementation of 16:1 mux using 4:1 mux. So in this structure, these are the select lines, 16 are the inputs, and 1 is the output. So we can see that there's a very simple method of implementation of higher order mux using the lower order mux. There is a generalized formula which I can discuss here. If I have to implement, suppose I have to implement 16:1 mux using 4:1 mux, using 2:1 mux, using 8:1 mux. So the point is, general point is, we have to divide this 16 using this 4. So if I divide this 4 and take the greatest integer value, it will give you 4. Now this 4 is divisible by again 4. It will give you 1. Now this 1 is not divisible by 4. So stop here. So total we have 5 multiplexers, or can say 5 4:1 multiplexers used to implement the 16:1 multiplexer. If the same thing we do for implementation of 16:1 mux using 2:1 mux, then first of all divide 16 using 2. It will give you 8. Now this 8 is again divisible by 2. So it is your 4. Now this 4 is again divisible by 2. It will give you 2. Now this 2 is again divisible by 2. 1. So total number of multiplexers, 2:1 multiplexer used to implement 16:1 multiplexers are 8, 4, 12 to 14, 15. So we can see that there are 15 2:1 mux required for the implementation of 16:1 mux. If the same thing is done for implementation of 16:1 mux using 8:1 mux, then we can see, divide this 2. But this 2 is not divisible by 8, so we cannot divide again. It means we can use only 2 8:1 mux. But when we use 2:1 MUX, then two outputs will be there. And for implementation of these two outputs, we can only use 1:1 MUX, because this value, what we have remained with, is only divisible by 2. So we can use 1:1 MUX. 1:1 MUX. So overall, we will use 3 MUX, where 2:1 MUX and 1:1 MUX. You can verify these things by taking your these examples by your own. So this is enough for the implementation of higher order MUX with the lower order MUX. So I tried my best here. If you find any problem, you can take the examples and can implement these higher MUX using the lower MUX. So this is enough for this video. Thank you.